So in this video, I'm doing the question on the Unit 2 review number 16, because there is a question like this on the exam. I find it to be one of the more difficult questions. So I wanted to show you how to do this one in a video just in case you were stuck on it. So I'm going to use this information to sketch my graph of f of x. Okay, so they said the limit as x approaches negative infinity equals -2. So what that means is as my x values go to negative infinity, so as I come to the left of my graph, the y value is going to get closer and closer to -2. So what I do for this is I usually draw like a dotted line at -2, not all the way across, just like on the left side of my graph, because it's only when x goes to negative infinity. And I know that my function is going to trace along this curve. Either it's going to be above it and going like that, or it's going to be below it and like coming down from that. And I have to use the rest of the information to figure that out. But I just put that there so I remember not to like go across that line as I go to negative infinity. So this says the domain is negative infinity to -3, union -3 to infinity, which means there is no point at x equals -3. And the reason they tell you is in the next one, there's a vertical asymptote at x equals -3. So at -3, I draw a vertical dotted line to show the asymptote, and my function cannot cross this. So it's going to be like two completely separate pieces, one to the left of -3 and one to the right. From there, I'm going to plot all the points that I know because I need to go through this. So I'm going to plot, this is my x, this is my y. So I'm going to plot x is -6, y is 0. Again, this is my x, this is my y. So x is 0, y is 2, 4, -1, and 8, 4. So my graph has to go through these 4 points, but I can't just like quickly connect it because I don't know which way it's going until I look at the rest of it. So I know the first derivative at 4 is 0. I know from negative infinity to -3, my function, my derivative is positive, so it's increasing, and also from 4 to infinity. So I like sign charts because they help me figure things out. It's completely up to you if you need them or not, or if you just want to use the information. Okay, so I have to put my vertical asymptote and I have to put my critical points for f prime, which is where it's 0. So I need -3 and 4. And I'm just going to write VA to indicate vertical asymptote and a 0 here because it's 0. And on my second derivative line, I also need the vertical asymptote, but then I need where the second derivative is 0, so it's going to be 8. And I'm going to line these up to help me with graphing it, because it will kind of help to see what's happening in each interval if they're lined up. Okay, so from negative infinity to -3, I know the first derivative is greater than 0, so it's positive. And also from 4 to infinity, so positive. I know it's less than 0 from -3 to 4, so it's negative. And then I'm going to fill in what I know from f. So because it's positive, f is increasing. Since the first derivative is negative, it's decreasing, positive, increasing. Okay, now vertical asymptote is never a max or a min, but 0 is going to be a min. Sorry, at 4, x equals 4, it's going to be a min because my function is decreasing and then increasing. I'm going to use the second derivative information for that sign chart. So from negative infinity to -3, my second derivative is greater than 0, which means it's positive. From -3 to 8, it is also positive. And then from 8 to infinity, it's negative. So this second derivative tells me concavity. If it's positive, it's concave up, up. And then if the second derivative is negative, it's down. So my point of inflection is at 8. So then I have to follow this and connect what I know based on this. Okay, and I would start left to right. Okay. So I know my function is increasing and concave up until I get to my vertical asymptote of -3. And I know it goes through this point, -6. And I know because it has to be like going through -6 and it's increasing, it's not going to go below this line here. It's going to trace it. So when I come from the left, I'm going to trace this function and I'm going to go through -6 and I'm going to be curved upward and increasing to match what this says, that it's increasing and concave up. And then you trace along a vertical asymptote. Okay, so then from the vertical asymptote, I know it's decreasing and concave up. It's decreasing until I get to this x out value 4, and it's concave up until I get to 8. So when you do a vertical asymptote, you always are either tracing it like this way, or you could come from down here and come up. But because it says that it's decreasing at this point, I'm going to start up and come down, and I have to go through the 2 points that I have, and I have to get to 4, and then at 4 that's a min, so I need to turn around and start going up, and I still want to be concave up until I get to 8, and then at 8 I want to start curving it down like this. And again, make sure this is labeled as a point of inflection. This one you can pretty much see. I mean, you can always write it just in case, like this is up, 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 down, but this one is more obvious than a lot of my graphs. And then make sure that at 4 we have a min and we don't have any maxes or anything else. So this is what this graph would look like. So let me know if you have any questions. I hope these help.